and a hearty welcome to one and all. I, Smriti Mahajan, on behalf of the primary wing of St. Teresa School, extend my heartfelt gratitude to our honorable directors, Shri Raman Raja Khanna sir and Shri Vijay Kumar Gulati sir, our revered principal, Mrs. Vibha Khanna ma'am, our diligent academic director, Mrs. Renu Srivastav ma'am, our dynamic headmistress, Mrs. Shivani Tripathi ma'am, and all our respected coordinators, teachers, parents and students for gracing this event with their presence. It is indeed a pleasure to have you among us. Today, our Environmental Science Cluster will showcase their presentation on the oceans, the breath of life. As rightly said by Jacques Cousteau, the oceans once casts its spell, holds fun in its net of wonder forever. Every second breath you take comes from the oceans that cover around 71% of the Earth's surface and represent around 99% of the living world. The ocean makes the Earth habitable for the living world. They form an essential component of the Earth's ecosystem and are critical to sustainable development. Despite being such a precious resource, the ocean is being threatened at an alarming rate by human activities. Through this presentation, we will highlight the importance of the oceans, the potential damage to the marine world, and the measures we can take to conserve it. This project aims to generate awareness among people about this much unexplored yet valuable resource. I would now like to invite Shruti to enrich us about the formation of the oceans.
Formation of the oceans. When the Earth was formed 4.6 billion years ago, it would have never been called the Blue Planet. There were no oceans, there was no oxygen in the atmosphere, and no life. But there were violent collisions, explosions, and eruptions. In fact, the Earth in its earliest stage was molten. This allowed elements to separate into layers within the Earth. Gravity pulled dense elements towards the Earth's center, while less dense materials accumulated near the surface. This process of separation created the layers of the Earth as we know them. As temperatures cooled, the surface solidified and an atmosphere was created. Volcanic eruptions released water vapor from the Earth's crust, while more water came from asteroids and comets that collided with the Earth. About 4 billion years ago, temperatures cooled enough for oceans to begin forming. Scientists have developed a number of hypotheses about how the oceans formed. Though these hypotheses have changed over time, one idea now has a wide support of Earth scientists, called the volcanic outgassing theory. This means the water given off by volcanoes erupting over millions or billions of years cooled and condensed to form Earth's oceans. Now, my friend Ishan will brief us on the formation of ocean basins we see today on Earth.
Present ocean formation. The continents were not always in the same shape or position as they are today. Because of tectonic plate movements, land masses have moved about the Earth since they were created. The Himalayas are a prime example of how tectonic plate motion can manipulate the Earth in extraordinary ways. The Himalayas once formed the seabed of the Dead Sea. It was pushed upward slowly over a long period of time. Some 40 to 50 million years ago, these colliding plates have resulted in the formation of the highest mountain range on the planet. About 250 million years ago, the continents were arranged in a huge mass of land called Pangaea. This meant that most of Earth's water was collected in a huge ocean called Penthalsa. About 180 million years ago, Pangaea had begun to break apart because of continental drift. This then separated the Penthalsa Ocean into separate but connected oceans that are the ocean basins we see today on the Earth. Now, My friend Mandar will take you to a wonderful journey over the oceans of the world.
Oceans of the world. While there is only one global ocean, the vast body of water that covers 71% of the earth is geographically divided into distinct named regions: the Pacific Ocean, the Atlantic Ocean, the Indian Ocean, the Southern Ocean, and the Arctic Ocean. Let's know some facts about these oceans. Pacific Ocean. The Pacific Ocean is the biggest ocean in the world. It reaches from North and South America to Asia and Australia. A line of volcanoes known as Ring of Fire surrounds the Pacific Ocean. It is also home to the Great Barrier Reef, which is the largest coral reef in the world. Challenger Deep, the deepest point on Earth, is in the Pacific Ocean. Atlantic Ocean. The Atlantic Ocean is the second biggest ocean in the world. It reaches from North and South America to Europe and Africa. The Atlantic Ocean is huge, but only half the size of the Pacific Ocean. The Mid-Atlantic Ridge, the longest mountain range in the world, is underwater in the Atlantic Ocean. Indian Ocean. The Indian Ocean is the third biggest ocean in the world. It is named after the country of India. The Indian Ocean is home to many endangered sea creatures including turtles, seals, and dugongs, also known as sea cows. Southern Ocean. The Southern Ocean is the second smallest ocean in the world. It is also known as the Antarctic Ocean, as it surrounds the Antarctica. It is the coldest and wildest ocean in the world. The Southern Ocean is home to emperor penguins, blue whales, elephant seals, giant squid, and the wandering albatross. Arctic Ocean. The Arctic Ocean is the smallest ocean in the world. It surrounds the Arctic. Often, the Arctic Ocean is completely covered in ice. Polar bears live on the ice that covers the ocean and can swim in the water. After a wonderful journey through these amazing ocean basins, let us now understand how deep is the ocean. My friend Rania will brief us about the depth of the ocean.
How deep is ocean? Today, scientists know that on average the ocean is 12,100 feet or 3.7 kilometers deep, but many parts are much shallower or deeper. The deepest part of the ocean is called Challenger Deep and is located beneath the Western Pacific Ocean in the southern end of the Mariana Trench. Challenger Deep is approximately 36,200 feet deep. To measure the depth, navigators use sonar, which stands for sound navigation and ranging. A ship sends out pulses of sound energy and measures depth based on how quickly the sound travels back. Let's see actually how this is done. Sonar is a system for detection of underwater objects by reflecting or emitting sounds. It stands for sound navigation and ranging. It uses ultrasonic waves to detect objects underwater. Ultrasonic waves produced from the transmitter kept in a ship directed towards the ocean floor. The ocean floor reflects these waves. We measure the time interval T between the generation of waves and reception of echo. We calculate the depth of the ocean using the relation depth of the ocean is equal to velocity of ultrasonic sound waves multiplied by time interval divided by 2, where V is equal to velocity of ultrasonic sound waves, T is equal to depth of the ocean. As oceans are very deep bodies of water, they are home to abundant life. We divide the ocean into different layers depending upon the penetration of sunlight and temperature and pressure. Now my friend Harshita will brief us about the layers of the ocean.
Layers of the ocean. Scientists have divided the ocean into 5 main layers. These layers are known as zones. These zones extend from the surface to the most extreme depth where light can no longer penetrate. This model is about different layers of the ocean. Through this model, we can understand about the different layers. This is the first layer, the sunlight zone. It extends from 0 meter to 100 meter. This is the second layer, the twilight zone. It extends from 200 meter to 1000 meter. This is the third layer, the midnight zone. It extends from 1000 meter to 4000 meter. This is the fourth layer, the lower midnight zone. It extends from 4000 meter to 6000 meter. This is the fifth and the lowest layer, the trenches. It extends to depth lower than 6000 meter. Now let us have a closer look at the zone. Sunlight zone. The sunlight zone is also called the epipelagic zone. In this zone, most of the ocean organisms live because it receives maximum number of the sunlight. It extends 200 meter below the surface of the sea. Plants such as seaweed, phytoplankton and other flowering plants live in this zone as they can get sunlight to perform photosynthesis. Most types of fish and animals live in this zone, including dolphins, turtles, rays, seals, coral and jellyfish live in this zone. The temperature here is 12 degree to 20 degrees Celsius. The pressure here is 1 atmosphere, which is same as 1 kg weight on your fingernail. Now my friend Niharika will share some facts about the twilight zone and the midnight zone.
The twilight zone. This layer is also known as the mesopelagic zone. It extends from 200 to 1000 meter below the surface. Very little sunlight reaches this zone. Animals such as whales, shrimps, swordfish, hatchetfish and octopuses live in this zone. You will also find sponges living at these depths. People often think that they are plants, but they are actually seasons, non-moving animals. The temperature in this zone is 4 to 13 degrees Celsius and the pressure here is 29 to 88 atmospheres, which is the same as 29 kg to 88 kg weight on your fingernail. The midnight zone. This layer is also known as the bathypelagic zone. It extends from 1000 to 4000 meter below the surface. Sunlight does not reach this layer. You will find animals such as larger whales, squid, anchonoids and blobfish living at these depths. The only light in this zone is produced by bioluminescent animals such as anglerfish. The temperature in this zone is 4 degrees Celsius and the pressure here is 100 to 393 atmospheres, which is the same as 100 kg to 393 kg weight on your fingernail. Now my friend Ananya will tell you about the lower midnight zone and the trenches.
The lower midnight zone or the abyss zone. This layer is also known as the abyssopelagic zone. Conditions in this zone are extremely dark and the temperatures are very cold. It extends from 4000 to 6000 meter below the surface. This zone is the largest environment on Earth. The deepest point of the Arctic Ocean is 5450 meters below sea level. The organisms that live in this zone include sea spiders, basket stars, medusa and sea pigs. The temperature in this zone is 0 degrees Celsius. The pressure here is 400 to 590 atmospheres, which is same as the 400 kg to 590 kg weight on your fingernail. The trenches. This layer is also known as the hydropelagic zone. It is pitch black and temperatures are very cool. It extends from 6,000 meters to the depth of the ocean. Some fish live in this zone, such as ractail fish and leprid fish. Amphipods wait for scarce food to drop down. Decapods, which eat amphipods, also live in this zone. Most animals living in this zone are unable to see. Challenger Deep in the Mariana Trench is the deepest place on Earth. The temperature in this zone is 0 degrees Celsius. The pressure here is 600 to 1000 atmospheres, which is same as a 600 kg to 1000 kg weight on your fingernail.
What a fascinating journey through the layers of the ocean. The ocean is indeed a mystery. Let us now hold our breath to know some more fascinating and interesting facts about our blue world. The ocean is home to nearly 95% of all life. With so much going on well below the surface, it's easy to forget that the oceans are teeming with life. In fact, 95% of life is aquatic. That means those of us who live on land are part of a very, very small minority. The Pacific is wider than the moon. At its widest point, from Indonesia all the way to Colombia, the Pacific Ocean is wider than the moon. The expanse of the ocean is 12,300 miles across, which is 5 times more than the diameter of the moon. Corals produce its own sunscreen. Too much sunlight can damage the algae that live inside coral in shallow water. To protect the algae, which are a main source of sustenance for the corals, the chlorophyllus. This creates a protein that acts as a sort of sunscreen for the algae. There's enough gold in the ocean for each of us to have 9 pounds of it. The ocean floor has undissolved gold embedded in it, but it is not cost effective to mine it. However, if the ocean's gold were equally distributed among every person on earth, we would receive 9 pounds of gold. One iceberg could supply 1 million people with drinking water for 5 years. Doesn't that sound unbelievable? But it is true. A large iceberg from Antarctica contains more than 20 billion gallons of water, which could conceivably supply 1 million people with drinking water for 5 years. A company in the United Arab Emirates is actually planning to begin towing icebergs from Antarctica to the coast for exactly this reason. The country receives, on average, just 4 inches of rainfall each year and is at risk of serious drought in the next 25 years, but may be able to solve the problem with this iceberg water solution. Doesn't that sound great? Now, let us move ahead to explore more about this endless blue world.
Isn't that mind-blowing? Now, I would like to invite my friend Arnav to explain why the ocean appears blue to us.
Why is the ocean blue? See through a glass of water. It reveals nothing but a transparent liquid. However, when we see the ocean water, it appears blue. Let us try to understand why this happens. Sunlight is a mixture of 7 visible colors. These are red, orange, yellow, green, blue, indigo, and violet. When sunlight falls on the ocean, it passes deep into the water. Here, the red, orange, yellow, and green colors are absorbed more strongly by water molecules, while blue, indigo, and violet colors are not absorbed much. Instead, they are scattered, making the ocean appear blue to us. However, as the blue shades penetrate deeper into the ocean, eventually they also get absorbed. Hence, at a greater depth, the ocean is completely dark. Well, a glass of water is transparent as there are not enough water molecules to really absorb the light. Now, my friend Kriti will explain us why the ocean water is salty and show us how to extract the salt from seawater.
Why is the ocean salty? Take a sip of seawater. How does that taste? Salty? Now the big question is, what makes it salty? Let's try to understand. Several natural processes makes the ocean water salty. Salt in the ocean mainly comes from two sources. Runoff from lands and underwater volcanoes and hydrothermal vents in the seafloor. Let's try to make salt from the seawater through a simple process. Salt, it's on everyone's table. In fact, we need salt to stay alive. If you did not get any salt, you would die. But do you know where it comes from? Table salt mostly comes from two places, the ocean and the salt mines. Today, we are going to experiment with the salt by dissolving it and then seeing what happens when the water it is dissolved in evaporates. Let's start with a list of required materials for this experiment. You need a clear drinking glass and a bowl, access to tap water, 1/4 cup of table salt, a spoon. Fill the drinking glass about halfway with warm tap water. Pour the 1/4 cup of table salt into the water. Stir the solution until the salt is dissolved. If it doesn't all dissolve, add more water to it. Let the solution sit for a day or keep it in sunlight. I kept it in sunlight until the water is evaporated. The sun evaporates the water, leaving behind solid salt or salt crystals. This is how salt is obtained from the oceans. Apart from providing salt, our oceans serve us in many ways. Now my friend Anika will give us some insight about the importance on the oceans.
Importance of oceans. The oceans make the earth habitable for humankind, but much of the oceans remains a mystery to us. There are some facts which we do not know about this precious resource. These mighty oceans provide us with the air we breathe. Phytoplankton, a tiny plant-like organism that lives in the sea, are responsible for at least 50% of oxygen on Earth. Just like land-based plants, they contain chlorophyll that captures sunlight and do photosynthesis and produce oxygen as a byproduct. They also consume carbon dioxide, transferring about 10 gigatons of carbon dioxide each year from atmosphere into the oceans. The oceans absorb about 30% of carbon dioxide produced by humans, limiting the impact of global warming. The oceans are responsible for regulating global climate, temperature, and weather patterns. Over 3 billion people depend on ocean for their protein requirement. Not only are they source of food, but also home to abundant life. Ocean-based industries employ a number of people worldwide, especially in fisheries and tourism industries. The ocean provides us convenient transport routes. Around 90% of all trades between countries is carried out by ships, which transport everything from food to fuel to construction materials, chemicals, and household items. Oceans serve as a great place for recreations, from fishing to boating to kayaking and whale watching. The ocean provides us many unique activities. Many medicinal products also come from oceans, including ingredients that help fight cancer, arthritis, and heart diseases. Now my friend Kanak will discuss about formation and extraction of oil from seabed.
Formation and extraction of oil from seabeds. Ocean beds are reservoirs of oil. But where does this oil come from? Oil is what we call fossil fuels. About 2 billion years ago, marine organisms like algae, zooplankton, phytoplankton, and other microscopic plants and animals died and settled at the bottom of the ocean. Beneath are the sediments, and in the absence of oxygen, these fossils changed into a substance called kerogen. Under heat and pressure, kerogen gradually changes into oil or gas. This process usually takes 1 million years. Extraction of oil from seabeds. Extraction of petroleum is the process by which usable petroleum is drawn out from beneath the surface of the earth. Offshore petroleum exploration and development are so prominent in this century because of the growing demand of petroleum and petroleum products. Oil is extracted by giant drilling machines. These machines drill a hole through the rock into the oil or gas reservoirs. The crude oil travels up through the borehole. For undersea deposits, these drills are mounted on a huge platform called oil drill platform. Oil and gas is then pumped ashore through pipelines. But these oil formation and extraction activities add to marine pollution. Now my friend Ritisha will make us aware of other factors which add to marine pollution.
Marine pollution, ocean pollution, also called marine pollution, is the build-up of harmful substances in the Earth's water systems, including oil, plastics, debris, industrial or agricultural waste, chemicals, and even noise. These harmful substances result from human activities and interfere with marine organisms and upset the balance of the Earth's ecosystem. There are several top contributing factors when it comes to ocean pollution. Land runoff. One of the most significant sources of oceanic pollution is runoff, which occurs when rivers, rainwater, floods, and other water sources carry pollutants from inland out to the ocean. Wind and weather. The wind often picks up trash and debris, carrying it over miles and miles, and some of these objects end up in the ocean. One notable example of the amount of marine debris in our oceans is the Great Pacific Garbage Patch of trash trapped in ocean currents in the Pacific Ocean of Texas, made up of approximately 100,000 metric tons of plastics, wood pulp, and other contaminants. Ships. While most ocean pollution starts on land, some ocean pollution originates in the water, especially with ships. These vessels often discharge oil, lost cargo, leak cargo, residue, and contribute to noise pollution since noise travels further underwater than above it. Offshore drilling. Deep sea mining and oil drilling are two significant contributors to ocean pollution, water columns toxicity. For example, in 2010, the Deepwater Horizon drilling rig's failure caused 210 million US gallons of oil to be discharged into the Gulf of Mexico. Now my friend Kathy will discuss about oil spills and its impact on marine life.
Oil spills. An oil spill is the release of a liquid petroleum into the environment, especially the marine ecosystem, due to human activity and is a form of pollution. Spills can be caused by: first, people making mistakes or being careless; second, equipment breaking down; third, natural disasters such as hurricanes, storms, or high winds; fourth, deliberate acts by terrorists, acts of war, or illegal dumping. Impact of oil spill on marine life. Heavily furred marine mammals exposed to oil spills are affected in similar ways. Oil coats the fur of sea otters and seals, reducing its insulating effect and leading to fluctuations in body temperature and hypothermia. Oil can also blind an animal, leaving it defenseless. The ingestion of oil causes dehydration and impairs the digestive process. Animals can be poisoned or may die from oil entering in the lungs or liver. Depending on just where and when a spill happens, from a few up to hundreds or thousands of birds, fish, mammals, reptiles, corals, and other animals and plants can be killed or injured. The impact can be understood by a recent incident of 2021 Israel oil spill that was an ecological disaster which occurred in February 2021. Dozens to hundreds of tons of tar washed up on the beaches with a 160-kilometer stretch of Israel Mediterranean coast. Numerous sea animals such as fish, sea turtles, and seabirds were found washed up and covered with a black sticky film. Several volunteers taking part in massive cleanup operation complained of malaise after inhaling the toxic fumes generated from the spills. From this, we can understand the extent of damage such spills can cause to ecosystem.
My friend Tanush will now explain and demonstrate one simple way to clean oil spills.
The ways to clean oil spills. The response to an oil spill has several goals. Foremost, to stop the flow of the oil or chemical, but also to protect sensitive areas that could be harmed by the spill itself, and to safely remove the oil from the environment as quickly and efficiently as possible. In most spills, a combination of methods are used. Which method to be selected depends on the circumstances of each event, weather of that area, type and amount of oil spilled, how far away from the shore the oil has spilled, whether or not people live in that area, what kinds of animal and bird habitat are there in that area, and many more factors. Let us see a simple method of using oil boom technology to clear the oil spills. An oil containment boom is a large temporary floating device that used to contain oil or the chemical spilled in the water area. When the oil releases into the oceans, it naturally floats to the surface rather than sink to the bottom or hover in the middle. Let us see a simple experiment. Materials required for the experiment are bowl filled with water, sponge, foam, empty bowl, and oil. Now I will take the oil and put it inside the water. Can you see the oil is floating in the water? That's because the water is denser than the oil. Now I will take the foam and put the oil at a corner, and take the sponge and remove the oil. Now can you see there is some oil left that will be eaten up by the water bacteria. Oil spills have a devastating effect on our environment, so we need to spread awareness to preserve it from further damage. Now my friend Kitika will discuss about some ways to preserve our marine resources.
Preserving our precious resources. There are some other simple ways in which we can contribute towards preserving our precious resource. First, conserve water. Use less water so that excess runoff and wastewater will not flow into the oceans. Second, reduce pollutants. Choose non-toxic chemicals and dispose of herbicides, pesticides and cleaning products properly. Avoid chemical fertilizers and use natural fertilizers like H manure and compost. Third, buy less plastic and bring a reusable bag. Opt for multi-use utensils. Fourth, recycle waste to reduce the amount of waste generated. Fifth, reduce the amount of energy that you use daily in order to reduce the number of fossil fuels we burn. Opt for energy efficient appliances. Turn light off when not in use. Sixth, we should become a part of ocean conservation campaigns and participate in creating awareness among people. Now let us discuss about some alternatives which can be used in order to reduce the usage of fossil fuels and save our oceans and lands from the further damage. Now my friend Manya will tell you about one such alternative.
Electric cars. Cars produce a lot of carbon emissions that are ejected into our natural atmosphere, leaving us vulnerable to pollution and greenhouse gases. In order to positively help the environment we live in, an electric car is a great step forward. An electric car uses an electric motor instead of an internal combustion engine. It is powered by a large battery pack placed in the car, which can be recharged. Charging an electric car can be done at a variety of charging stations. These charging stations can be installed in both houses and public areas. Advantages of electric cars. First, it will decrease the dependency on fuels like petrol, diesel, and other gases. Second, it will run on cheaper costs. Third, they are eco-friendly as they run on electrically powered engines. Fourth, it requires low maintenance as compared to an internal combustion engine car. Fifth, electric cars keep a check on noise pollution as they are much quieter. With improving technologies, the battery life of an electric car is expected to increase further and the cost to come down even more. Electric cars have the simplest driving method, making them easy to drive. The Bengal government has proposed a special intercity corridor which can be used only by electric vehicles with charging stations at every 25 kilometers. This is an attempt to phase out fossil fuel vehicles and encourage more and more people to use battery-driven cars. The state is targeting to use 10 lakh battery-driven cars by 2030. Now my friend Anya will discuss about another alternative to fossil fuel, which is biogas.
Gobar gas, the starting material for production of biogas, is mainly cow dung. That is gobar. Hence it is known as gobar gas. Gobar gas is also known as biogas. Its main component is animal dung, gobar, along with other organic matter like dead remains of plants and animals. It can be used for cooking, generating electricity and heating purposes. With the continuing development of science and technology, it is considered that gobar gas will be one of the biggest fuel providing resource in the future. Indeed, introducing a community to a safer, greener and more eco-friendly energy option will make their lives happier and much more sustainable in the long run and protect the forest. Advantages of gobar gas. First, it reduces burden on forest and fossil fuels. Second, it provides a clean fuel which helps in controlling air pollution. Third, it provides nutrient-rich manure for plants. Fourth, it controls water pollution by decomposing sewage, animal dung and human excreta. Now, my friend Chaitanya will discuss about next alternative, that is solar power, and will explain how a solar cooker works.
Solar power, unlimited source of energy. The sun is the ultimate source of life on earth. Solar energy is useful to us in many different ways. It is the key to a clean energy future. That's why we should invest heavily in solar plants. Let's see how we can harness solar energy to cook food by using a solar cooker. Today, I am going to tell you all about solar cooker. A solar cooker is a device in which heat energy from sunlight is trapped inside the cooker using the phenomena of greenhouse effect. A solar heating device such as a solar cooker uses a reflector to reflect sunlight in a small area where the cooking container is placed. We normally use a stove or an oven for making rice or oats. Using a solar cooker, we cook the same things, but by using sunlight instead of gas or electricity. Let us discuss the working and construction of a solar cooker. For this, we need a mirror, black box, glass lid, and a cooking container with some oats. The mirror is mounted on the box to concentrate light rays onto the box, and it is adjusted in a way such that the strong beam of light enters the box through the glass sheet. The box is painted black from the inside to absorb the maximum heat. It is covered with a glass lid to produce a greenhouse effect inside it. The food absorbs heat from the black surface and gets cooked. The thick glass sheet does not allow the heat to escape and thus helps in raising the temperature to a sufficiently too high degree to cook the food. I kept this bowl of oats an hour ago, and as you can see, it's cooked and ready to eat. The best thing about this solar cooker is that no fuel is used. This saves cost as well as the environment while not contributing to pollution.
As discussed by my friends, these alternatives can reduce our dependence on the fossil fuels and reduce pollution of our precious resources and make our planet a cleaner and greener place to live. The need of the hour is to improve science and technology to use these alternative resources to its best. So now, let us enjoy some fascinating facts and test our knowledge about the ocean world. So let's get started.
Most of Earth's volcanic activity happens in the oceans. When it comes to volcanic activity, the oceans have the most going on by a wide margin. In fact, 90% of all the volcanic activity on the planet happens in the oceans, and the largest known concentration of active volcanoes is in the South Pacific. It's an area no bigger than the size of New York, but it contains a whopping 1,133 volcanoes. Sea ice is drinkable. You can't drink seawater, but you can drink sea ice. However, you don't want to drink fresh sea ice which still has little pockets of brine trapped in between ice crystals. As the ice ages, the brine drains out and the ice becomes fresh enough that it can be melted and consumed. More people have been to the moon than to the Mariana Trench. In human history, 12 people have set foot on the moon, but just 3 people have managed to make it to the Mariana Trench because of the extreme conditions there. One of those people is director James Cameron. Planet's biggest waterfall is in the ocean. The tallest waterfall you're going to see on land is Angel Falls in Venezuela, which has a drop of over 3,200 feet. But that's nothing compared to the Denmark Strait Cataract, which is an underwater waterfall in between Greenland and Iceland, formed by the temperature difference in the water on either side of the strait. When the cold water from the east hits the warmer water from the west, it flows underneath the warm water with a drop of 11,500 feet. The flow rate of waterfall is more than 123 million cubic feet per second, which is 50,000 times that of Niagara Falls. Water at the bottom of the ocean is incredibly hot at some places. In the deepest parts of the oceans, the water temperature may be 2 degrees to 4 degrees Celsius, with the exception of water coming out of hydrothermal vents in the seafloor. The water released from these vents can go up to 400 degrees Celsius. It's the intense pressure at these depths that keeps the water from boiling.
So it's quiz time. We have got something nice for you today. Are you all excited to witness this quiz? We will take you to the journey of series of questions. We hope you all enjoy it and able to answer all of them. So let's start with the first question. How much of the Earth's surface is covered by oceans? And your options are 50%, 71%, 92%. Yes, you are correct. It is 71%. as less than 1% of the Earth's surface is fresh water and 2 to 3% is contained in the form of glaciers and ice caps. Our next question is, what percentage of Earth's living species exist within the ocean? And your options are 47%, 71%, or 94%. Yes, you are correct. It is 94%. That's almost all living creatures. Moving ahead with our next question, how much of the planet's oceans have been explored? And your options are less than 5%, nearly 20%, or over 50%. Yes, you're correct. It is less than 5%. Or we can say more is known about the surface of the moon than the depths of the ocean. Our next question is, how many islands are found within the world's largest ocean, the Pacific? Your options are 2,500, 15,000, 25,000. Yes, the correct answer is 25,000. There are about 25,000 islands in the Pacific Ocean. These islands can be divided into three main groups known as Micronesia, Melanesia, and Polynesia. Last but not the least, the Great Barrier Reef off the coast of Australia is the world's largest living structure. How big is it? Your options are 1,340 square miles, 13,400 square miles, or 1,34,000 square miles. Yes, the correct answer is 1,34,000 square miles. The interesting fact here is the coral reef is so huge that it can actually be seen from outer space. Life began in our oceans, and these aquatic wonderlands still remain the cornerstone of life on Earth today. They are fundamental in sustaining our everyday lives, which is why now, more than ever, the protection of marine environment is imperative.
Wow, that was truly amazing. The Earth's ocean are a world of mystery, magic, and beauty. As we come towards the end of our program, I extend my heartfelt gratitude to each and everyone who spared time from their busy schedule to join us. I hope our presentation has helped in exploring and creating awareness among us to save our precious resources. We realize the countless benefits provided by our oceans. So, it is our utmost duty and responsibility to save oceans and marine life from pollution, oil spills, and other possible danger. If we don't start reducing climate change and preserving our oceans, we'll suffer in the near future, and so will all life forms. In fact, some of the damage has already been done. If we want to save our oceans and ourselves, we'll have to act now. Together, we can protect and restore our oceans. The sooner, the better. Thank you.